Greetings, Math 10 students. In this video we're going to do something a little bit different. A lot of people have mentioned that they've had a hard time completing HOX section 6.1 and 6.2, so I'm going to take a look at a few of the questions in both of these sections, some of the ones that I think I've had the most questions about, and work over them so that you have a template that you can follow when you go ahead and do these. So I'm going to start with section 6.1. And these ones aren't too bad. I haven't had as many complaints about this particular section, and I'm not worried too much about the plotting points, although just to give a demonstration of how that works in HOX, if they ask you to plot a point like this or graph a point like this, all you're doing is, and I'm going to actually, well, we'll go ahead and do this one. I'm going to take a look at that first number is telling us how far to go in the x direction, and the second one is telling us how far to go in the y direction. So taking a look at the video for section 6.1, you probably remember that x is left right and y is up down, but if not, that's something you want to practice. So this is telling me to go to the right, not at all, and this is telling me to go down by 5. So I'm going to go on the graph, starting at the center where the two lines meet, the x and y axis. I'm going to go right, not at all, and I'm going to go down 5 and click to make that point. If you accidentally click somewhere that's wrong, you can hover over the point, drag it to the right spot, and drop it. And this is actually pretty forgiving, this particular question at least. Most of these graphing questions are forgiving. If I am kind of close but not quite at the right spot, it will snap to the correct place. The question that I wanted to look at from here was this one right here, actually. The questions that like this that ask you to create the input-output table. And this one's kind of funky because they give you a y value, which we're not used to. We're used to always taking x numbers and plugging them in. So I'm going to go over how this particular question works. So if you have not seen the videos for 6.1 and 6.2, this might be an alien idea to you, but we're just going to make a table, and we're given a value for x, and we're just going to replace that x in the equation with that value. So my equation is y equals, and actually let me do this the easy way. Forget that I have my paint program, so I can actually just type this, y equals 4 times x plus 5. So what I'm going to do, I'm going to take the value for x that they gave me, which is -2, and here what I'm going to do when I'm using this table, I'm replacing the value for x here, this x, with the number they gave me, the -2. So that x is going to turn into a -2, but everything else will stay exactly the same. So it's going to be y equals, didn't mean that to change colors, y stays the same, equal stays the same, 4 stays the same, and my x is going to become a -2, and you typically see that written in parentheses just so that you remember it's a multiplication. And then the plus 5 comes down. And then it's a matter of computation. You're going to do the calculations. 4 times a -2 is a -8. And then -8 plus 5, got to be careful with the signs here. Since the signs are different, I subtract those, and you'll get a 3, and you keep the sign of whoever's bigger. Well, 8's bigger than 5, so I'm going to keep the negative sign that was with the 8. So I put in a -2, and I get a -3 as my result. Alright, the second part has thrown people off here, because instead of giving you an input, they're giving you an output. They're telling you what y is. So in this case, I'm taking the y and replacing that with 1. So this is totally different. Instead of y equals, I'm going to write 1 equals, oh, again, I forgot to change colors back. 1 equals, and then the 4x plus 5 just comes down. So what on earth are we going to do with this? We're going to go back to the week 7 material, and actually this is something you could have done in week 4. We're going to solve for x. So I've got to cancel out the numbers on the side with x. So I'll start with the -5, and then 1 minus 5 is -4 equals 4x, comes straight down. And then last but not least, I've got to cancel out the coefficient of 4, so I'll divide by 4 and do it on this side as well. Well, 4 divided by 4 is 1, but it's a negative divided by a positive, so I get a -1 equals x. So that's going to be my x value here. Go ahead and type in my -1. Now next they will ask you to graph this, and that's just the same as the other graphing points were. The only other question that people have, the only other question that people have asked about in this particular section is the Fahrenheit one, this guy right here. And I think the fraction people find a little bit frightening. Well, guess what? One thing you can do, just a little tip with this question, is this is a very easy one where you can convert that fraction to a decimal. If you've forgotten the process for that, to convert a fraction to a decimal, you can always go back and watch the video, but this particular fraction will always be 9/5. And to convert a fraction to a decimal, you just divide. 9 divided by 5 is 1.8. So if you want, you can use the equation f equals 1.8c plus 32, and it works just the same. And that's a little bit easier. You don't have to do the fraction arithmetic. You can do it with decimals instead. Some people prefer that. Some people are really into the fractions and would rather do it with fractions, and that's fine too. Alright, so I'm going to end this, and I'm going to take a look at section 6.2. And there are a couple of questions that I want to do in there. You can see I'm overdue on all my assignments. Let's take a look at section 6.2 here. I'm going to start practice. And there are two types of questions in here that I think people have asked about mostly. And so we'll take a look at those. Actually, this is not one of the ones that people asked about, but I want to do this one anyway because this one it's so simple that it looks funny and it throws people off. So being a little bit impromptu here, and I'm going to go ahead and do 3 questions from this section instead of the 2 that I had originally planned. So for this, I can do my xy table. The equation is simply enough y equals x. And this is just such a simple equation that it almost feels like you're doing something wrong. But for this, in this section 6.2, you can choose whatever values of x you want. So I'm going to go ahead and pick, I don't know, 1 and 2. You could have picked any numbers though. And I'm going to take my x, just like the other input-output tables, just like the other xy tables. I'm going to replace x with the number that that we picked. So I'm going to bring down the y, and it's going to be y equals. I'm going to replace x with the 1, and there it is. Y equals 1. So your y value is exactly the same as the x. Feels like cheating because you didn't do any work, but that's all you have to do. And the same thing's going to happen here. Y, I bring down my equal sign, and I replace the x with the number that I chose for x, which is 2 in this case. Now it's telling me y equals 2. And so there are my 2 points. 1, 1 for xy, and then 2, 2. So I'll go over 1 and up 1 for my first point, and then over 2 and up 2 for my second point. Whenever you see this really simple equation, that's what's going to happen. Sometimes you'll see y equals negative x. That doesn't mean you have to put in a negative input. That just means you replace the x with that number and then bring the negative sign down. So those ones are so simple that I think they throw people off sometimes. This is the one that I wanted to take a look at, these fraction ones here. So when you're dealing with fractions, now in section 6.3 we'll learn a shortcut, the slope-intercept method, but that won't work here because they want an input and an output. They want you to actually do the table. So when you're dealing with these fractions in the equation, I have 2 recommendations for the values for x that you choose. You're allowed to choose whatever values you want for x, but I'm going to encourage you to select 0 and the denominator for x. Why am I encouraging you to use those 2 numbers? Because it'll make the computations come out much easier. So let's take a look at what the xy table looks like here. If the denominator happens to give you a value that's bigger than 10 or less than negative 10, you can also use the negative version of the denominator, just make it negative, and that works too. But these 2 numbers will always make it so that you get nice, clean, whole number values for y. The fractions will always cancel out. So let's see what happens here. I'm going to take 0 as my first input for x. I didn't have to. I could have chosen 1 or 5 or whatever, but I'm going to choose 0. And what happens, I'm going to write down my equation. I'm going to bring everything down until I hit that x, and I'll replace x with 0. So the y comes down, the equals comes down, the 5/2 comes down, and x gets replaced with 0 plus 2. Well, you don't have to know a thing about fractions. What's 5/2 times 0? Anything times 0 is 0. That just cancels out, and you're just left with 2. Pretty easy, right? And in fact, that's going to happen whenever you use 0 for x. You're just going to be left with whatever this number on the end is. And as we'll see, that actually is important. I'm going to type in my 0 for my x and my 2 for my y. And you'll notice that points right on the y-axis because x is 0. So a little trick that you'll see in section 6.3 is whenever you put in 0 for x, you get this number here for your y. So this number has a special name. It's called the y-intercept because it's where that dot will go on the y-axis when x is 0. So for my next number, I'm going to take the 2 as my denominator. So I'm going to take the 2 and make that my input. And I'm going to rewrite the equation, and when I see x, I'm going to replace it with 2. So bring down my y, bring down my equals, bring down my 5/2, and then I see an x, so I'm going to replace that with 2 in parentheses. And I'm writing it up here because I'm going to need to make that thing a fraction, and I do that by putting it over 1, and then plus 2. Alright, so things cross-cancel here. I can cross-cancel with this fraction multiplication. This 2 cancels with this 2. 2 divided by 2 is just 1. And I end up with 5 times 1 over 1 times 1. Now, a bunch of 1s there aren't going to change anything. That's going to be 5 over 1, or just plain old 5. In other words, the only important thing to survive that multiplication is this numerator of 5. And I can bring down the plus 2. If that was a bit quick for you, you can go ahead and pause and rewatch it. Or I encourage you, even better, to work out the fraction multiplication on your own. 5 plus 2 is going to be 7. And so that's my output for y. So I get 2 and 7. And so what was the takeaway there? If I put in the denominator of 2 as my input, that means that the 2's cancel and I'm left with this numerator of 5 telling me to go up by 5, add 5 to my y-intercept of 2. So it's telling you, hey, you can go over 2 and then up 5. This is an idea called slope that, again, you'll see in section 6.3. Even though this is a 6.2 Hawks assignment, I'm just bringing these things up because we'll see them again. So that's how to deal with the fractions. Very last question that I want to deal with is this word problem. Now, I know that the word problems in this section, I actually did a similar one in the video for section 6.2. So you can watch the video for that to see this whole input-output table in action. I'm not going to spend too much time on that. No, of course it's not going to show me one. Here we go. So the one that I did was the taxi cab one. This is the pizza company one. It's very similar. I'm not going to go into too much detail about how to do the input-output table here, since we've done a few of those. The thing I want to talk about with this is the graphing portion of this, because that's a real pain. And this is something that is, if you're having a difficult time plotting the points, that's not your fault. It's a little bit the user interface here is difficult to work with. So y equals 0. Oh, I need my x first of all. And then y equals 0.5 x plus 7.25. So 50 cents per topping plus the $7.25 is the cost of that pizza if you read through the question. But I'm more worried about plotting the actual points. So I'll just pick a number like, let's say 1, and I get y equals 50 cents times 1, which is going to still be 50 cents, 0.5 times 1, and then plus the $7.25 ought to give me $7.75. So I apologize for the sloppy writing. What I should be doing is this. That should be $7.75. And so now I have a point. I've got 1 for x and 7.75 for y. So here's where things get a little bit tricky for this. Plotting points in this one is not like any of the other questions because you actually can put a dot right in the middle somewhere. it won't snap to the nearest corner, which is kind of annoying. So here are some workarounds. First of all, get rid of this word problem. Once you've got your 2 points, just slide that thing up. And then on a Windows computer, Control Plus will zoom in, and I think you actually have to do the bar thing after you do the Control Plus to zoom in. That gives you a little bit more visual space there. I'm going to just slide this over and just remember that it was 1 and 7.75. On a Mac, I think there's a similar technique for zooming in. I just don't know what it is, and I don't think anyone uses Linux in the class, but if you do, I apologize. I don't have a clue what you would do to zoom in, but on a PC it's Control Plus. So what do I do with this point? I need to go over 1 and then up 1, 2, 3, 4, 5. Okay, I got to go all the way up to 7.75, 6, 7, and then $7.75 is going to be somewhere between 7 and 8, so maybe right around there. Maybe should be a little bit higher, maybe right around there. Now, like I said, it doesn't automatically snap perfectly to the point that you want. Like this, my X is off. It's 1.25 instead of 1. The 7.75 is great. So what am I going to do? I'm going to go back and I'm going to drag it, but it will always tell you up here what your point that you plotted was, so you can go back and click it and drag it. So figure out where you're off. I'm off in the first coordinate, which is the X. X is always left to right. It was supposed to be a 1 and it's a 1.25, so it's too big. I need to make it smaller, which means since it's X left to right, I'm dragging it back to the left. So let's do that, and then I'm going to scroll up, and I made that mistake on purpose. Now I'm too small. So I'm going to see if I can drag it back over, and now it's just right, or it should be. Let's go and see. And yep, it's 1.0 exactly. Now my Y is too small. It should be 7.75, $7.75, and it's just $7.50. So I need to, since it's Y is up and down, I'm going to click on that and drag it up a bit. Now you might get it right on the first shot. That's great. You might not, in which case, click it and drag it. I know it's a bit frustrating, but zooming in can help. I'm going to zoom out here because I'm going to show you another thing. People get a little bit flustered with this because when you click it and drag it, it should, but it's not for some reason. It should tell you numbers along the way. If it doesn't, then that's actually better, because when it tells people numbers along the way, that's funny. I think it's probably browser dependent, because I was doing it in Google Chrome before and it was telling me numbers, and now when I click it and drag it around, it doesn't tell you numbers, but I'm in Firefox, so who knows. But when you click it and drag it, ignore those numbers, just look at the visual and then look at the numbers when you're done dragging it, because it will snap to a little bit. So it might say like 1 and 7.73 and you think, oh, I'm so close, I need to move it. Well, just let go and it'll snap to 7.75. Alright, so hopefully this has been helpful to you for dealing with these two Hawk sections. I'll probably record some videos for 6.3 and 6.4 because I'm assuming that those will also be a little bit problematic. And thank you for watching.